Hello everyone, I'm Sneha Mishra and this is the video for Lab2 assignment for my one of the courses Python Deep Learning for the fall semester 2018. I am from Team 14 with my team member Raju Nikari. The objective of this lab assignment is it has 4 subproblems and this has to get us familiar with the Python and machine learning terminologies as well as few of the very famous natural languages processes, classifying and evaluating a model, stemming, lemmatization, name entity recognitions, etc. So there are different data sets provided and we will be using cricket dataset, wine dataset and breast cancer dataset into our this lab assignment. So let's start with the part 1. So the first part is we have to pick any of the data sets and then we have to plot how many categories are available for that data set, and we have to use Seaborn library. So we have used wine data set and we created a data frame of named wine from that data set, and then we took just the top 5 rows from that data set and then we printed the unique ones, the unique classes from that value from values for the from the CSV file, and then we have printed the description of that. And when we run it, we see that these are the 3 unique classes that we saw, and over here we can see that alcohol, malic acid and hues and prolines were the ones that are 5 out of 14, 5 rows and 14 columns, because we took just 5 rows, just the headers, and then when we printed just the unique classes out of it. So these are the unique classes and there were 8 rows and 14 columns. So moving on to the next part was we have to create a prediction model based on the naive Bayes classification and evaluator model. So we again used the wine data set and we created a data frame, and then we checked the correlation in the wine data frame using the function CORR, and then we plotted the same using the Seaborn heat map. So this is the correlation that we calculated, and then we use the Seaborn heat map to get the correlation, and then we showed it, then we plotted it. So when we run it, we will see, so this is the plotting that we see, and then this is the naive Bayes prediction, which we'll see later. And then what we did was, since ASH was the least correlated amongst them, so we removed that column from our data sets, and then we found the labels, and then we split the test and the train data sets using 20 and 80%, and then we used Gaussian NB classification to train the sets using linear kernel. So this is how we are training the data sets, and then we predicted on the test data sets that was provided, and this is how all the printing printouts and the plottings. So as we can see, this was the prediction. So this is the prediction. The prediction is this, and these are the values given. And when we say the accuracy of naive Bayes classification, the training set was 98%, and on the test sets was 100%. Moving on to the next question. So, and we have given the objective and the data sets used. The code can be found here. I have attached the code snippets. The output and the workflow is also attached for your reference, and the parameters used and what is the conclusion. Moving on to part 2. The problem was we had to implement a support vector machine classification, and we had to apply poly and RBF kernels up to degree 4. And we had changed the gamma and the C parameters in the following model to see how the results change. Excuse me. And then we reported the accuracy of the model. So moving on to support vector miss. Okay, so we have used the wine data set again. We have converted into data frames, and then we again found the correlation between in the data frames using the same correlation function, and then we have plotted using the seaborne heat map, and then we have printed it out and removed the least correlated one, as in the previous example, and then we got the labels out of it, that is in the Y, and then we again split it into test and train data set. Now over here, so this is what is different. So what we have done is we have used SVCs, and the kernel is poly this time with the degree 4 and 2, and C is changed from 1 and 2, gamma is 0.1 and 1, and then we have fitted train models. So we have printed it out just to see the difference all the time. So this is the plot that we have, and over here we can see the accuracy when C is 1 and gamma is 0.1, then it's 100%, but on the train data set, but on the test data set it's 97.2. And again on the train data set, when gamma is 2, on the train it's again 100%, it doesn't change, but the test data set is 97.2, even though the C's value is increased from 1 to 2 for the poly kernel. Now when we move to RBF kernel, for the same C value and gamma value, we in the train data set we had 100% accuracy, but when it comes to test data set, it reduced to a drastic reduction was to 38.8% from 97.2 in the poly kernel. So that is what we have printed over here, and the objective again was to program learning all the machine learning repositories. We have imported all the matplotlib, seaborns, sklearn, and pandas. The Wine dataset was the dataset used. The code can be found here. I've attached the code snippets and the output snippets over here, and the conclusion was again with even though for the train data set it was the same for poly and RBF kernel, but when we moved to a test data set, it was drastically reduced in case of RBF kernel. Moving on to part 3. So the problem was that we had to take an input file from user, and then we had to give these of the following, so lemmatization diagram and etc and etc. So this one, so again we have asked users input on what they want to use file. So over here it's asking user, so I'll give suppose cricket.txt. it's over here one of the data sets that we have included. So it prints out all the things included in the problem statements. So what we did was then we opened that file and we got all the sentences. Then we tokenization. We used sentence and word tokenization on the sentences that we read from the file, and then we got all the singular and the plural words out of it, and then lemmatizers. Then we got all the lemmatizers on the plural values, and then we got the biograms as well, and we made it case insensitive, and then we extracted the phrases and removed the special characters just to create the biograms, and then we got the counter for the biograms, the count, and then we got and then we printed out all the outputs related to it. And let's see how so for cricket data set we got, these are the billions, rights, millions. These are the plural forms. The singular ones will be billion, right, million, and the frequency, that is the count of each words, that is 3 of these are in. And then the biograms, which are 3, are Tamil Nadu and Nadu, which we can see. And then most repeated biograms in the, and 5 most repeated biograms are this. And so final combined statements are below. So basically the summarization of that statement is over here. So The objective was to take input from the user and use NLTK library to apply lemmatization bigram on text and get the top 5 bigrams and find sentences which used to create the top 5 most repeated bigrams. Then the data sets we used were cricket and BC data sets. Um, we have included that in our report, but in the demo I've just given for cricket text file. The code can be found here. I've included the code snippet as well as the uh, evaluation and the output. And the conclusion is that is very efficient in performing NLP functions, NLTK libraries, and they work very well with all kinds of data. So moving on to the last problem statement. So we had to report our views on k nearest neighbors algorithm, KNN algorithm. When we change the k, how can it affect the accuracy? And then we have to justify and also compare the accuracy when k is 1 and k is a big number like 50 and why the accuracy changes. So KNN. So over here we have used the breast cancer data sets. So we have inputted the data sets and we got top 5 rows. We have split the data sets into independent and dependent variables x and y, and then also we have got the test and the train data sets of the size 80 and 20%, and then we have used k neighbor classifier, KNN classifier. Um, and then we started making predictions on the test data sets, and then we calculated the accuracy on the test and the prediction, and then we have printed it out, and then we again started creating a list of the CV scores, and then in each the list. So what we did was over here, because in the problem statement was given, we had to calculate the accuracy when k changes, and it has to be drastically between 1 and then 50. So we created a list of the various k values or the range of k's value that we can have, that is this k list between 150 and again 1, and then we try to calculate the CV scores on each k's value. So when k is 1, because k will we go through the for loop for k's different value through the list, and then we use the KNN classifier and get the scores, and then we printed it out, and then again we used misclassification error, and then we used the best value for k using the misclassification error. So, and then we printed it out and plotted it into a graph. Let me show it how it works. And so this is okay. So this is a misclassification error, and these are the number of k values. So it started with 1 and then went to 50. So when k's value was 1, misclassification error was highest, and then it reduced, and then again became constant around 30 to 50. So this is the plotting that we did, and over here we can see that accuracy prediction is 96%. When the on the training set it's 97, on the test set it is 96, and on the prediction it is 96.43, and it is optimal number of neighbor is 7. So the objective of this was to perform evaluations on different values of k parameters. The solution and the approach was, what we did was we understood basically what KNN models are and how it works and how k's value affects the accuracy, and over here in the data points based on how the neighbors in the classifiers stores the data, and the data set we used was breast cancer. The code can be found here. These are the snippets, code snippets that we have attached. The output and the workflow is over here. Evaluation is between 1 and 50, and used scores and misclassification errors generated and plotted using the Seaborn matplotlib. And we also see from the below graph that value of k increases, the accuracy of the model as the value of k increases, the accuracy decreases because it is highest at this point, and then so the best value for k breast cancer data set is 7. And this are the output that we just saw. Parameters are k from 1 to 4. Evaluation is that we can plot graph, and k increases the accuracy. So as the value of k increases, the accuracy decreases. And then conclusion is the choice of k is very critical. K is equal to 1 means noise with will have higher influence on results, and larger value of k makes computation expensive but higher misclassification error. So that will be all. Thank you.